Hello everyone, how are you all doing? Well, in today's video, let's discuss the three most important 7-marker questions. Here we have the first question on our screens. I is equal to 1001. Here I is a matrix. Alright. Then we have the second matrix, that is E is equal to 0100. Then show that AI plus BE whole cube is equal to A cube I plus 3A square BE. Now I'm sure you must be wondering what this A and B are. Alright, let me tell you. These A and B are the scalar multiples that we have previously discussed. Alright, now let's first consider the LHS part of our question, that is AI plus BE whole cube. Alright, this is what is the LHS part of our question. Now let's first find out AI and then BE and then cube them. Alright, that is simple. Now A into 1001. Alright, let me write it down. 1001 plus B into 0100 whole cube. Do not forget whole cube. Alright. Now what is this gonna be equal to? This is basically A into 1A, A into 0, 0, A into 0, 0, A into 1A. In that manner you're going to solve them. Plus 0B 0 0 whole cube. Fine, now let's add them. Alright. A plus 0 is 0. Is it 0? No. A plus 0 will be A. Then 0 plus B, B. Fine. 0 plus 0, 0 and A plus 0, A. Here we have our matrix. Do not forget to cube it. Fine. Now what is whole cube of this? This will be AB0A into AB0A into AB0A. Fine. Now firstly, let's find out AB0A into AB0A, and whatever the answer we get, you're going to multiply that with this third matrix. Alright. Take the first row with the first column. Fine. Again the same story. Right. Here we have the matrix which should be multiplied with AB0A later on. Fine. Now A into A plus B into 0. That is going to be A square. Isn't it? A square plus 0, that will be A square. So here let's write down A square. Then take the first row with the second column, that will be A into B, AB plus B into A, BA or AB. So AB plus AB will be 2AB. So here I am going to write down 2AB. Fine. Then the second row with the first column, that will be these two, isn't it? Now let's find out what they are. 0 into A plus A into 0. That will indeed be equal to 0. So here let me write down 0. Then moving forward, we have the second column. Alright. Now that is going to be equal to 0 into B plus A into A. That will be A square. So here we are going to have A square. Now this is a matrix which should be further multiplied with AB0A in order to find out the cube, right? Now let's find out what this will be equal to, right? Take the first row with the first column, that will be A square into A plus 0 into 2AB. So here you have A cube plus 0, that is A cube. So here we are going to have A cube. Then with the second column, that is BA, right? So A square into B plus 2AB into A. This is equal to a square b plus 2a square b. Now a square b plus 2a square b is 3a square b. So here let's write down 3a square b. Now we have the second row with the first column, that will be 0 into a plus a square into 0. It will be 0. Let's write down 0 over here. Then 0 into b plus 0 into b plus a square into a. Isn't it? With the second column. Fine, that is going to be 0 plus a cube. That will be a cube. Let's write down a cube over here. Now this right over here is the LHS part of a question. Fine. Let's put this aside for a while and then solve RHS. In the RHS part, we have a cube I plus 3a square be. Fine, let's first find out a cube I. Fine, that is simply going to be equal to a cube into 1001. Now this is a cube 00 a cube. Fine. Now let's consider 3a square be. 3a square be. That is going to be 3a square b into 0100. This is equal to 3a square b 00. Now we're going to add these two matrices as given in the question in the RHS part. Fine. Let's erase all of this. Now when you add them, you'll have 0 plus a cube. Here let's have a cube. 3a square b plus 0, 3a square b. Then 0 plus 0, 0, 0 plus a cube. Now this is RHS. Now if you take a look on the previous slide, that is LHS and RHS, they are completely equal. Therefore, LHS is equal to RHS. Hence, a cube I plus 3a square be is equal to ai plus be whole cube. Moving forward, we are being given with one matrix and we are asked to find out the adjoint and inverse of it. Before we even proceed to find out adjoint and inverse, let's find out the determinant of this particular matrix at the first case. Why? Because if determinant is 0, then there exists no inverse for A. So first let's find out determinant and then we'll proceed to find out adjoint and inverse simultaneously. Now, first cut down the rows and columns 2 belongs to. Here you have 0 into 1 minus 2 into 1. Now that is simply going to be equal to 0 minus 2, that is minus 2. This minus 2 further should be multiplied with 2, that will give you minus 4. Then cut down all the rows and columns. 1 belongs to. Here you have 1 into 1 minus 2 into 1. This is 1 minus 2, that is minus 1. Fine. This minus 1 should be multiplied with 1, that will give you minus 1 again. Then let's cut down the rows and columns. 2 belongs to right now. Then it will be 1 into 2 minus 0 into 2. This is gonna be equal to 2 minus 0, that is 2. Now this 2 again should be multiplied with 2. Here we have 4. Now let's find out the determinant. Here we are going to follow plus minus plus rule, isn't it? So minus 4 minus of minus 1 plus 4. That will be minus 4 plus 1 plus 4. Here it is going to be equal to 1. Since determinant is not 0, hence inverse of matrix actually exists. Let's move ahead and find out adjoint and inverse. In the previous slide, we have already found out minors of the first row. Those are minus 2, 1 and 2. Aren't they? Yes. Now let's find out for row 2, that is 1, 0, 1. Now cut down all the rows and columns 1 belongs to. Here you'll have 1 minus 4, that is minus 3. Here we are talking about B21, B22, B23. Now here the signs get changed for the cofactor matrix. That will be 3 over here. Fine. Then here let's cut down the rows and columns. 0 belongs to, and here you're going to have 2 minus 4, that is minus 2. And here let's have minus 2. Then B23 is going to be equal to, let's cut down the rows and columns. 1 belongs to. Now here you're going to have 4 minus 2, that is 2. Now here definitely the sign will get changed. So here you're going to have minus 2. Now for C31, C32, C33, let's find out them. Let's erase all of this. C31, C32, C33. That will be equal to, let's cut down the rows and columns. 2 belongs to, here 1 minus 0, that is 1. Now, well, it will be 1 only. Fine. Then the rows and columns 2 belongs to over here. Oh, let's wait. Let's cut down the rows and columns. 2 belongs to. Here you have 2 minus 2, that will be equal to 0. Let's write down 0 over here. Then let's cut down the rows and columns. 1 belongs to. Here you have 0 minus 1, that is minus 1. It will remain minus 1 only. This is our cofactor matrix. Now if you take the transpose of this matrix, you will find out the adjoint. Let's do that. That is gonna be equal to minus 2, 1, 2, 3, minus 2, minus 2, 1, 0, minus 1. This is our adjoint of A. Now in order to find out inverse, it is simply adjoint of A by determinant of A, that is 1. What is determinant of A, everyone? That was 1, isn't it? Now if you divide everything by 1, you get the same thing, right? Minus 2 by 1 will be minus 2, 3 by 1 will be 3, 1 by 1 will be 1. So this matrix is both the adjoint and inverse of A. Now this right over here is a word problem which says a certain bookshop has 10 dozen chemistry books, 8 dozen physics books, 10 dozen economics books. Their selling prices are so and so each respectively. Using matrix algebra, find the total value of the books in the shop. Now firstly, 10 dozen chemistry books means 10 into 12, that is 120, right? 8 dozen physics books, 8 into 12, 96. Then 10 dozen economics books, again 10 into 12, 120. This is our matrix A, let's say. Now this is not that hard. Well, let's see. Their selling prices are rupees 80, rupees 60 and rupees 40 each respectively. Let me draw column matrix over here. 80, 60, 40 is equal to matrix P. Remember, there are two separate matrices. You are not going to club them in one matrix. Now, using matrix algebra, find the total value of the books in the shop. Now, forget all of this matrices and all. Let me tell you that you got to buy 2 chocolates. Fine. Each having 5 rupees. Now, what are you going to do? How much amount of money are you going to give to the shopkeeper? 1 chocolate is 5 rupees. 2 chocolates will be 5 times 2 or 2 times 5, that is 10 rupees. Isn't it? Now that is what it is over here. Here you are being given with the number of books that are there and you are being given with the cost. You're simply going to multiply A and B in order to find out the total cost, not simply the cost that 120 books are going to cost each, right? It is the total cost. Fine. Now for that you need to multiply A, B. Now let me tell you, even if you multiply A, B or BA, does not matter over here. Let me tell you why. Here in this matrix, you have just one row and one column. It does not even make sense if you multiply 80 into 120 or 96 into 60. Now, what am I telling over here? Here you need to multiply the corresponding elements. You have no other choice left for you. Fine. That is here going to be 9600 plus, what is 96 times 60? 96 times 6 is 36. Here 54 plus 3 is 57. So you have 5760 plus 120 times 40. That is 4800. Now here add all of them. Now make note that even if you do 80 into 120, it is the same 9600. Even if you do 60 into 96, it is the same 5760. Fine. Now that's not a concern when it comes to only one column or one row matrices. Okay, fine. Now let's add all of these. What is this gonna be equal to? 9600, 5760, 4800. Let's add all of them. You have 6 plus 8 is 14 plus 7, that is 21. Here 9 plus 9, 19, 18, 18 plus 2 is 20. So what is our amount over here? Rupees 20,160 is the total value of the books that are available in the shop. Well, that dives us to the end. Make sure you hit the like button, share and subscribe. Thank you.